Number 1, we needed to solve this one by substitution. So going back through our steps, one of these needs to be equal to x or y. It doesn't really matter which one, but the easiest one was in to solve for this y because it's by itself or has a coefficient of 1. If we solve for this y, we get this equation, y equals negative 3x plus 5. Once we get that equation, we can take this part, the negative 3x plus 5, and put it back into the other one where y is. So that's the start of this. I should have arrows. So we're taking this piece, we're putting it into the other equation. Now we only have one variable, our x's, so we can start solving for x, distribute, combine like terms, solve for x to get x equals 1. Once we solve for x, you can then put that back into our equation. So I just put it back into the one we solved for to find what our value of y was. And then once we got our value of y, the final answer should be an ordered pair with both of them, 1, 2. Did everyone get that one? Anyone have questions on that one? For number 2, you had to solve this by graphing. So graph both lines and see where they intersect or if they intersect. Without graphing, you could look at the two equations. You may need to change the order of the second one. But you can see that they don't have the same slope. They don't have the same coefficients. So they aren't parallel lines and they aren't the same line. So these would have to be one solution. And that solution would be 4, 3 when we got them. Did we get that solution? Some yeses, some no's. Anyone have questions on 2? Anyone still need to see 1 or 2? For number 3, you needed to solve that one by elimination. You may have done this differently than the way I did this, and that's okay. Because remember, you can choose whether you want to eliminate your x's or your y's. You have that choice. I chose to eliminate my x's, so I made my x values the same. I also went too high. I did 24, multiplied these to get 24, but I could have done 12. I just wasn't thinking. So if you got rid of your x's and you did 12, that's fine. You should still get the same thing. What you multiply doesn't really matter as long as it still works out the same and the math is correct. So since I got 24, these were both positive, so I need to subtract. My x's would eliminate. And I get 58y and 116, divide both, and I get 2 for my y value. Then I could put that y value back into any of these equations. And I put it back into this original one, 4x plus 5y equals 6, to solve for x. So I solved for x, and then I found my ordered pair to be negative 1, 2. Anyone else eliminate their x's? A couple of you. 5. The x is 12. Like, you want me to show that example right now? I won't do it fully, but I'll show you what the 2 new examples would be. So if x is 12, you would multiply this first one by 3. You don't need to write this down, but if you wanted to train yourself, you could. This should be fun. My brain is not working today. And multiply the bottom by 2. You would still subtract, because these are both positive, to get 29y. And whatever that is. 29y and 58. Oh, you're adding, yeah. So when you divide, you would still get y equals 2. And then the rest of that process will be the same. If you got rid of your y, your lowest number I think was 35. So you have to multiply 1 by 7, 1 by 5. You could have went higher than that, and then 70. That would have also worked. You have any other questions on number 3? Number 4, they're asking, is this point a solution? So that was like one of the first things we did when we talked about graphing. Not one of the first, but it was in that lesson. We would take this ordered pair and put it in for both of these and determine, does it work for both? If it does, the answer is yes. If it doesn't, the answer is no. So when I put this into the first, it works out 7 equals 7. But when I put it into the second, it does not. So this cannot be a solution because it doesn't work out for both. Questions on number 4? For number 5, they give you an equation and ask us to write another equation that would make this have infinitely many solutions. Well, in order for it to have infinitely many, it would need to be exactly the same. So I changed this to slope-intercept form and then just rewrote it. But if you didn't need to do that, you could have just wrote this again.
I wrote down an equation that was the same thing as the given equation, but everything was negative.
So you had negative 3x minus y equals negative 4. I feel but let's see. So that would be 3x. And divide by negative 4. Yes, it would.
I wrote it.
Okay. Then yes. If you were thinking they would eliminate and both become 0, then yes, that would work. You could also check it, and they are the same. You could have also changed it completely. Make sure I'm saying this right. I think if I had something where it was like this, but maybe I just multiplied this by 3 or something like that, I think it should work the same, but I just made that up so it could not, and I don't really want to work it out. So we'll just leave it at that. there are other answers you could have given. That's what I'm trying to get at. Do we have any other questions on this? You know, it's been a little bit since we've done like the graphing and the substitution. Hopefully that came back to you. Today, we're going to be doing word problems, and we're going to be using all three methods, kind of going through them one by one to show you that you can use any of the methods for the word problem. Just want to double check one more time. Did anyone have Delta Math or Khan Academy questions before we start our notes for today? Going to take that as a note. So you should have these notes in front of you. Make sure you find those over there. We're not going to do every single problem together because I do want you to try some. Also, you have a blank piece of paper at the back, but instead of flipping back and forth, it'd probably be easier if you just got out another blank sheet of paper. If you need some, I have some back there. That way you can do your work. The first couple of problems, you have space to do them, but when we get to the maze, you won't really have space. With our word problems, what is the first thing we need to do always? Read it. Read it, yes. And then once we read it, what do we do with that? Highlight, circle, underline, anything we find that's important. So, let's read it together. For example 1, a snack bar sells large and small nachos. Large nachos cost $5 and a small pack of nachos costs $3. In one day, the snack bar sold 60 packs of nachos for a total of $220. Let L be the number of large nachos and S be the number of small nachos. Write a system of equations to model the situation and determine how many large and small packs of nachos were sold. What do we feel is important here? Go ahead.
The price of both types of nachos, how much they sold in one day, and the total of how much they sold. Does that make sense? So the number of packs and the number of how much that costs.
Anything else we find important?
The variables.
The variables. And what are we looking for?
How many packs of nachos there were of each type?
After we know everything that is important, then we can start to put this together. So once we know all of our numbers and variables and things like that, sometimes you'll be given your variables, sometimes you won't be, and you'll have to define them. So if we don't have variables, we would need to say x equals whatever. Because they give us our variables, we don't need to define them, but if we did need to define them, whatever it's looking for would be how we define them. So here we're looking for large and small packs of nachos. That's why L is for the number of large and S is for the number of small nachos. Right. Now we have to put these together in an equation. Let's start off with something we know. We know our total is 220, or That's the total price. So we can say one of our equations, this is still a system, so we still need two. One of our equations is going to equal 220. These things tend to go together, so if we're looking for a total price, things that have money should also be in this. Okay.
It would be, your variable L and how much it costs, so 5L plus 3S.
In this case, because we know our costs, we're going to include this, but also we need to multiply that by our number, because if we knew how many we sold and we multiplied it by the price, we would get the total price. 5 S plus. I'm going to write S in a different color so we don't confuse it for a 5. Okay, that's one of them. Do we have another total? Okay. $60. 60 represents the total number of packs altogether. What else here represents number of packs of nachos? L and S. That means we're going to add L and S here to equal 60. Okay. All of these problems can be solved either of the three methods: substitution, elimination, factoring. The first few examples we're going to choose, and then after that I'm going to let you guys, I'm going to choose, and then after that I'm going to let you guys choose. So for this one, we're going to solve this one by elimination. So in order to eliminate these, one of these have to be the same. Do we want to get rid of S or L first? S. Yeah. So in order to get rid of S, we would need to multiply this by 5. So I'm going to rewrite this first one down here. And then our new equation here would be 5S plus 5L equals, I think that's 300. Would we add or subtract to eliminate these? Subtract. So when we subtract these, this would give us 3L minus 5L, which is 2L. 220 minus 300 would give us negative 80. Okay, that's negative 2L. With these word problems, just like we've done before, we shouldn't get negative numbers. So if you're if you end up with a negative, you probably forgot a negative somewhere because it should have canceled out or something like that. So when we divide both sides by negative 2, we get L equals 40. 40 what? What are we looking for? Packs of nachos, large nachos, either of those. Sometimes with these word problems, you'll only be asked to find one thing, sometimes you'll be asked to find two things. In our case, we have to find the other one. What's nice is because we had this equation that was s plus L equals 60, we could put that back in and figure out what s is. But if this is 60 and this is 40, what does s have to be? 20. I'll do it still so we recognize what it is, but sometimes you don't have to necessarily put it back in because the math is reasonable. Not all the time. Some take longer than others. Some are set up better than others for specific ways. So this one, really, elimination may have not have been the best way to solve it, but it was one way to solve it. We could have easily converted this and made it a graphing problem. We could have also changed this to a substitution problem because we have an S and an L by itself. It's really your preference. Before we move on to the next one, do we have any questions on how we set this up, how we solved it, got the answers? We're not going to do example 2 because I'm going to let you try that one. Skip to example 3. Take a second and read it. What did we find was important in this?
$2.30.
Okay. So the 2 pairs were $30.
Yeah.
The letters. The letters. E is the cost of earrings. S is the cost of her shoes. Mariana, this entire sentence. Each pair of shoes costs $2 more than 4 times the cost of earrings.
5 pairs.
Okay, go ahead.
5 pairs.
Oh, this should also be included, yes. And then say, what are we looking for?
I was going to say.
Okay. Anyone, what are we looking for?
We're trying to find the cost for one pair of shoes.
Sorry. So again, we are given variables, so we don't need to define them. Do we have a total here?
$30.
30. So I can say one of my equations is definitely going to include that. It's going to equal 30. Let's change this one. I'm gonna keep S blue. Okay. To get the cost of 30, we need to know the number of and the cost of, and put those both in this equation. Anyone want to take a guess as to how we would write this equation?
5e plus 2s.
5e, because e is the cost of earrings, so if we took 5 and multiplied it by the cost, we would get the total cost of all the earrings. And then 2s, if we knew the cost of shoes and multiplied it by 2, we would get the total cost of shoes. E plus 2s. That is one of them. Then we know that each pair of shoes costs $2 more than 4 times the cost of earrings.
4e plus 2.
So here is talking about the shoes. And S equals 4e plus 2 or 2 plus 4e, that part doesn't really matter. Right. So in this case, because we already have a variable solved by itself, this is a really good substitution problem, which is what I was going to say. So we could take this and put it into our S up here. Rewrite that first equation. So it's 5e plus 2 times 4e plus 2 equals 30. Mm-hmm. 5e plus 8e plus 4 equals 30.
And then you do 5e plus 8e.
To get 13. Times 4.
Divide the 2 by 13. Get to e is 2.
And our units here would be dollars, because we're looking for costs. So $2, we can write out dollars. So now that we know our cost of E, we can go back, put that in our S equation and find S. I believe that is correct. We could also double check this. We didn't do this for the last one, but we could do this here. If I put these two numbers back into this equation, 5 times 2 is 10. 2 times 10 is 20. 20 plus 10 is 30. So that works. And we know it works for the second one. Any questions on how we set this one up, solve this one, or got this answer? Move on to example 4. And then I'm going to let you guys go back and do example 2, and then we'll start on the main. Right, read this one. And what's important here?
Three, 3.70 times and quarters. And we have 5 more quarters than dimes. And D be the number of dimes and Q be the number of quarters.
And what are we looking for?
How many dimes and how many quarters?
Dimes, how many quarters? Alright. This one's going to be set up a little differently, but more or less the same. Do we have any totals?
70
The 370.
plus
Yes and no. If I have just D plus Q, D and Q represent the number of dimes and the number of quarters. So,
Or the amount.
the
So
amount.
would it be 10.1, yeah, 0.1 D plus 0.25 Q?
Yes. So in these, we can just put D plus Q equals whatever, because that would just tell me, like, if I had 10 and 5, I have 10 dimes and 5 quarters. 15 doesn't equal 370. But if you took the worth of whatever you have, then that could help you find the total amount you have. So we have to kind of bring in some outside information. It's assumed that you know the worth of a dime and a quarter. So we could write this as, just as Kat said, 0.10 D plus 0.25. I heard that way too fast. Okay, that's one. Our other one is going to deal with this 5 more quarters than dimes. Anyone want to take a guess as to that one? Okay, so Kat said Q equals 5 plus D. Anyone agree with that? Venus, did you have something different? Sadie, did you have something different?
What is this about the quarters? We just touch and get $1.
Not times. So more than here would be adding. Abby, did you have something different?
That's right.
Okay. So with these questions, that wording is like the most confusing thing. Think about it like this. If you knew the number of dimes and you added 5 to it, you would get the number of quarters. So yes, what Kat said is correct. Q equals D plus 5. You kind of have to think about it backwards to kind of write out that equation. Now, even though this is really set up for a substitution problem, we're going to solve it by graphing. So there are 2 ways you could go about graphing. One in your calculator, one in Desmos. So if you have your computer with you, you could pull that up to pull out Desmos. We will go over both ways, so then you'll have that choice. Yeah. So you wouldn't actually graph it unless the numbers were small enough to do that. You would really show me how you would set it up if you did it in the calculator. If you did it in Desmos, really I would need to see if you needed to define your variables, that. Let's say they were already defined but they weren't X and Y like ours aren't. show me how you change them to X and Y, and then tell me that you did it in Desmos.
Okay.
And then give the answer. Alright, I'm going to show the calculator first, so if you're getting your computer up and ready for Desmos, you'll have time to put up. So if you're doing this in the calculator, we all know that our calculator is not like Desmos, has to be specific ways. So if we were to put these in our calculator, they would need to be in slope-intercept form. First, we need to have x's and y's, which we don't right now. It doesn't matter which variable you choose to be x or y, but whichever one you choose needs to be consistent. So let's say I make dx, then in both they need to be x. If I make dy, then they both need to be y. That part doesn't matter. So I'm going to say my d is now x, and my q is now y. If it helps you to actually see it, rewrite it. So then, in this case, one of them is already in slope-intercept form, the other is not. So we need to solve this first one so that it's in slope-intercept form. Let me rewrite that over here. How would we get this into slope-intercept form? We have the x term on both sides. Abu, tell me the next step to the zero.
And then we divide it all the way by 0.
I'm going to also switch these, so negative 0.10x plus 3.7, 0. And we're dividing everything by 0.25. When you are writing these decimals, write them as 0 point whatever. That way you don't just write it as point whatever and forget that there's a decimal, and then you end up doing times 25 instead of 0.25, because that gets really messy really fast. I don't know what those are off the top of my head, so you guys are going to have to tell me.
Negative 0.4.
And then x plus 14. Plus 14. 28. If these are nice fractions, you could leave them as fractions, but that's completely up to you. If they're nice decimals, leave them as decimals. If they're repeating decimals, leave them as fractions. Now we have our two equations. Now we can put them in our calculator. Reset it if you haven't already. Second plus 712. Go into your y equals and put in your two equations into y1 and y2. Doesn't matter which one you put in either or. Once you have both of these in, graph it, make sure that your intersection can be seen on this. Right now, it can't be, so we're going to need to zoom out. So zoom, you can do one of two things. You can either zoom out, or you can zoom fit, I think is 0. I always do zoom fit, because usually that works. Zoom out also works, you may just need to do it a couple times. Zoom fit, you could count this think about your word problem, what it's asking you for. Because we're looking for how many dimes and how many quarters, these should not be decimal answers because we can't have point whatever of either. So you should be able to count this, but let's say they're too close together and you're not sure, or maybe you miscount. To avoid all of that, you can have the calculator count it for you. Go back to second trace, not go back to, go to. And what are we looking for? Enter. Number 5. And then you're going to hit enter, I think, 3 times. 1, 2. Yes. Hit enter 3 times. So if you're using your calculator, what you would do is write down this ordered pair, 7, 12. And then you would need to go back and tell me which one is which. So our x's here, we use D for our x's. And then Y was our quarters. Do we have any questions on how we put this in the calculator to solve it by graphing? Some of these will be nice enough that we could actually graph it if we wanted to. And there'll be actual graphs where you could do that. Some of them, the numbers will be too big, so I'll say avoid that. As long as you show me this, you're good. Now, if you're using Desmos, of course, we know that we don't need to solve these equations for x or y. I'm sorry, for y. They don't need to be in slope intercept form. They do, however, need to be in xy. They need to have the variables xy. So you would still need to change the variables to xy if they're not already. So you would still need to show me how you change them if you're using Desmos. So if you're using Desmos, I would see this, I would see this, and I would see your answer. I wouldn't see any of this. But to show you how you put that in Desmos, let's do that really fast. So one of our equations, 0.1x plus 0.25y equals 370, or 3.7. And then the other one, y equals x plus 5. And you may need to zoom out to figure out where they intersect. Once you see where they intersect, you can click on that intersection point, 7, 12. And again, you would write that down as xy, and then tell me what x and y were. So basically the same as putting it in the calculator, but you don't need to solve it. So less things you need to show me. So calculator, all of this, Desmos, just this. Do we have any questions on how we solve this by graphing in the calculator or in Desmos? Okay. I'm going to stop talking for a minute. I want you guys to go back and do example 2 if you haven't already. Try that one, and then we'll come back and we'll talk about it. Depending on how much time we have, we'll start the maze or not. Going over the answer to number 2, I don't think this is solved in every single way. It's solved by graphing and substitution, not elimination. So if you want to see that, I can do that. If you solve it by substitution, that's the method in purple. If you solve it by graphing, I just use Desmos. Either way, you should have got 5 how many acts and 7 singing acts. Anyone have a question about that or need to see the elimination method? So if you didn't get a piece of paper before, make sure you get that out now, unless you're going to flip back and forth between the back and the maze. I will say it would be very easy to go through all of these and just do graphing, but then you would only get practice at graphing. So we are going to rotate the ones we do. But I'm going to choose. With this, some of these are nice because they give us the answers already. And we're not looking for 2 things, we're only looking for 1. So that kind of helps us also. So let's start with this first one. And then we may have time to do 2, we may only have time to do 1. Why didn't we do that? I'm just outlining it so we know which one we're at. Alright, take a second and read this. Find your important information. What did we find was important here? Diana? Okay. Anything else you see that's important? I'm gonna
The other cabinet bought connected popcorn and 5 popcorn drinks.
And then, what are we looking for? How much is a fountain drink? So we're not looking for the cost of the popcorn, but just the fountain drink. First, how do we want to solve this? Anyone want to solve this by substitution? Anyone want to solve this by elimination? Elimination, and then anyone for graphing? I'm just counting who wants to do which. I only had 1 vote, and that was elimination, so we'll do that. There's a way to. That's this is for the start. So this, you're going to need to do this on somewhere else on a separate sheet of paper, on the back, something like that. We don't have variables. We need to define our variables. What don't we know? Graham? Yes. We don't know how much is a fountain drink, how much is popcorn. So you can call that F and P, X and Y, it doesn't matter. So this is going to be the cost of 1 fountain drink. And the cost of a bag of popcorn. So So in all of these, if you are not given variables, you need to define them. For the two equations, do we have totals?
Yes,
Yes, what are they?
22, 16, and 23, 75.
So because these totals are based on these specific families, that means all the numbers that one family had are going to go with that total. And all the other numbers are going to go with the other. So 4 fountain drinks and 3 bags of popcorn. How would we write that into the equation? Yes. No. Using that same logic for our second one, we have 5f plus 2p. So we've defined our variables, we've set up our equation, we determined that we're going to solve this by substitution, by elimination. Yes, this is huge now. I want to count everything. Hold on. That's all right. I'll just do this one. If we're solving this by elimination, are we getting, first, we're looking for the cost of a fountain drink. If we're eliminating this, we need to get rid of what we don't need, P. Because if we get rid of P, then we can just focus on F. So let's get rid of P. What are the number P's both go into? 6. So if I multiply this first one by 2 and this bottom one by 3, that would work. So we'd have 8f plus 6p equals some number, 43. Someone tell me what that is. 22. What did you say?
45.
45. And then 15f plus 6p equals, what is 3 times 23.75? 71.25? Is that what you said? Is that what you said? And then to eliminate these, we would add or subtract. Subtract. So we have 8 minus 15, or negative 7f. Someone subtract 45 and 71.25.
Negative 26.
I hear the 26, but thank you. I was like, I am not catching the second part. And then divide that by negative 7. $3.77. So when we do this maze, we know the next direction we're going to go is this way. So we're going to stop there. If you want to continue working on this on your own, that's fine. We are going to do this and only this next class, and then you'll have time to practice. So you can do that and then you know the answers, but then we're still gonna go over this. So I would just wait.